Early morning, December 8, 1941. The Philippine Islands. Lieutenant Satoshi Kuroda stood in the turret of his Type 97 Chiha medium tank, watching American M3 Stuart light tanks maneuver in the distance near Damortis. His crew had trained for this moment. They understood their mission: engage the enemy armor, destroy it, and clear the path for the infantry advance that would sweep the Americans from Luzon within weeks. Kuroda's tank mounted a 57mm gun. The American Stuarts carried 37mm weapons. The engagement seemed balanced, almost fair. His crew fired first. The round struck an American tank's turret and bounced away, leaving only a dent. The Stuart returned fire. Kuroda's tank shuddered from the impact, but the armor held. Both sides withdrew after a brief exchange, claiming tactical success in their reports. That first tank battle between Japanese and American forces in the Pacific established a dangerous pattern of thinking that would haunt Japanese armor doctrine for the next 4 years. Kuroda and thousands of tank crews like him believed their equipment was adequate, perhaps even superior, for the battles ahead. They had defeated Chinese armor in Manchuria. They had crushed British colonial forces in Malaya who barely possessed any tanks at all. They had pushed American forces steadily back across the Philippines in those early months. Victory after victory reinforced the belief that Japanese tanks, while lighter than European designs, were perfectly suited for Pacific warfare. Then the Americans brought Shermans, and everything changed. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The moment of revelation would not come during combat. It would come in a quiet examination, in captured equipment being studied by Japanese technical officers who suddenly understood the true scale of the technological gap they faced. The mathematics of armor penetration, the physics of shaped charges, the industrial capacity required to produce such machines in quantity, all of it would become painfully, undeniably clear, not through propaganda or intelligence reports that could be dismissed or rationalized, but through direct physical evidence that could not be explained away. This is the story of how Japanese armor crews discovered they had been fighting with obsolete equipment against an industrial superpower whose production capacity exceeded anything they had imagined. It begins not with a battle, but with a single captured tank and the officers who examined it closely enough to recognize the implications. Summer, 1943. Munda Point, New Georgia, Solomon Islands. Japanese forces had just lost another defensive position to American amphibious assault. The withdrawal was chaotic, rushed, with equipment abandoned across the airfield and surrounding jungle. Among the abandoned American equipment sat an M4A2 Sherman medium tank, disabled by a mine but otherwise intact. The tank had belonged to the 10th Marine Defense Battalion, knocked out during the advance but not destroyed. Marine crews had removed some equipment before withdrawing to regroup for the next assault, but the basic vehicle remained operational after field repairs. Japanese engineers from the 6th Independent Engineer Regiment reached it first, recognizing immediately the intelligence value of an intact enemy tank. This Sherman, serial number USA 30542816, built by the Fisher Tank Arsenal in Grand Blanc, Michigan, became the first complete American medium tank captured by Japanese forces in the Pacific. The vehicle was towed to a secure area behind Japanese lines, while technical officers from the 8th Fleet headquarters were notified. Within 3 days, a team of armor specialists arrived to conduct a comprehensive examination. The team leader was Colonel Takeshi Hayashi, a veteran of the Manchurian tank development programs who had personally overseen testing of captured Soviet BT-7 tanks after the Khalkhin Gol battles in 1939. Hayashi understood armor design principles. He knew what to look for. He arrived expecting to find a competent design, perhaps even an impressive one given American industrial capabilities. What he found instead shook his fundamental assumptions about the relative capabilities of Japanese and American armor. The first shock came from simple measurements. The Sherman's frontal hull armor measured 51 millimeters thick, angled at 56 degrees from vertical. Japanese armor officers calculated the effective thickness against armor-piercing projectiles. The angle increased protection equivalent to approximately 75 millimeters of vertical armor. They measured again to confirm. The numbers didn't change. The Type 97 Chi-Ha, Japan's most numerous medium tank, had 25 millimeters of frontal armor angled at 15 degrees. The Sherman had 3 times the actual thickness and far better angles. But the revelation that disturbed Hayashi most profoundly came when his team examined the Sherman's main armament and calculated its penetration capabilities against Japanese armor. The Sherman mounted a 75mm M3 gun, a weapon derived from the French Malay 1897 field gun, but modified extensively for anti-tank use. The gun's specifications were readily apparent from examining the breech mechanism and measuring the barrel length. 40 calibers long, meaning the barrel length was 40 times the diameter of the bore, standard for tank guns of that generation. Hayashi ordered his gunnery specialist, Captain Ichiro Watanabe, to calculate the penetration performance using standard formulas based on projectile weight, muzzle velocity estimates from barrel length, and the known metallurgy of American armor-piercing shot. Watanabe spent 2 hours working through the calculations, checking his figures repeatedly. The results seemed impossible, but the mathematics was straightforward and undeniable. The Sherman's 75mm gun, firing standard armor-piercing ammunition, could penetrate 50 millimeters of vertical armor plate at 1,000 meters distance. At closer ranges, penetration increased significantly. At 500 meters, the gun could defeat 65 millimeters of armor. The exact effective range against Japanese tanks depended on angle of impact and which tank was being engaged, but the basic conclusion was inescapable. Every Japanese tank in service could be penetrated by the Sherman's main gun from ranges exceeding 2,000 yards under favorable conditions. The Type 97 Chi-Ha, with its 25mm frontal armor, could be destroyed from over 3,000 yards. The Type 95 Ha-Go light tank with 12mm of armor could be penetrated at virtually any combat range. Even the newest Type 3, Chi-Nu, which existed only as prototypes and mounted 50mm of frontal armor, could be engaged successfully at 1,000 yards or more. Hayashi stood beside the captured Sherman as Watanabe explained the calculations. Other officers gathered around, examining the figures, checking the assumptions. No one could find an error. The penetration estimates were conservative, based on projectile types Japan knew the Americans possessed. If the United States had developed improved armor-piercing ammunition, and Hayashi had to assume they had given American industrial sophistication, the actual performance would be even better. One officer, Major Kenji Tanaka from the 4th Tank Regiment, asked the obvious question. At what range could Japanese tank guns penetrate the Sherman's armor? Watanabe already had those figures prepared. He had calculated them, knowing someone would ask. The Type 97 Chi-Ha's 57mm gun could penetrate 51mm of vertical armor at approximately 400 meters under ideal conditions of perpendicular impact. But the Sherman's frontal armor wasn't vertical. It was angled at 56 degrees, which increased the effective thickness significantly. Accounting for the angle, the Chi-Ha's gun could only reliably penetrate the Sherman's frontal armor at ranges under 300 meters, and that assumed a direct hit at 90 degrees impact angle. Any deviation reduced penetration further. The Type 95 Ha-Go's 37mm gun was even less capable. It could not reliably penetrate the Sherman's frontal armor at any range. The 37mm armor-piercing shot lacked sufficient energy to defeat 51mm of angled armor plate even at point-blank range. Ha-Go crews would need to target the Sherman's thinner side armor, which was still 38mm thick, or the rear armor at 38mm. Even those shots required close range, under 200 meters, to guarantee penetration. The tactical implications were devastating. Japanese tanks would need to close to within 300 meters, often much closer, to have any chance of destroying a Sherman from the front. The Sherman could engage Japanese tanks effectively at over 2,000 yards, more than 6 times the effective range of Japanese guns against American armor. In any engagement where both sides could see each other, The Americans would fire first, fire more accurately due to superior optics and stabilization, and achieve kills before Japanese tanks could even hope to return effective fire. Hayashi ordered a complete documentation of every system on the Sherman. His team spent 5 days examining the vehicle, measuring components, sketching layouts, photographing details. They crawled through the interior, noting the spaciousness compared to Japanese designs. They examined the turret, marveling at the power traverse system that could rotate the massive assembly smoothly and quickly. They studied the transmission, recognizing the robust construction and the synchronized gears that made driving easier. They measured the track width and calculated ground pressure, understanding how the Sherman could traverse soft ground that would bog down Japanese tanks. Every discovery reinforced the same conclusion. This was a mature design from an advanced industrial nation with decades of automotive engineering experience. Japan had nothing comparable. The engineering philosophy differed fundamentally from Japanese approaches, where Japanese designers sacrificed crew comfort and ease of operation to minimize weight and maximize mobility. American designers had built in generous margins everywhere. The crew compartment was spacious enough for men to work effectively during extended operations. The ammunition storage was organized logically with racks that kept rounds secure but accessible. The vision equipment was extensive, with multiple periscopes for each crew member. The communication system included radio equipment as standard, not as a luxury item installed only in command vehicles. The mechanical systems revealed similar philosophical differences. The Continental R975 radial engine in this particular Sherman was a proven design derived from aircraft engine technology and adapted for tank use. It produced 400 horsepower, more than enough to move the 31-ton vehicle at 25 miles per hour on roads. The cooling system was robust, designed to operate in desert heat and tropical humidity. The air filtration system could handle dust and sand without clogging. Every component reflected design thinking that prioritized reliability and maintainability over achieving maximum theoretical performance. Captain Watanabe examined the gun mount and fire control equipment with particular attention. The Sherman's 75mm gun was stabilized in the vertical axis, allowing reasonably accurate fire even while the tank was moving. This capability, impossible on Japanese tanks that relied entirely on manual gun laying, gave American crews an enormous tactical advantage. They could shoot on the move, maintaining offensive pressure while Japanese tanks had to stop, aim carefully, and fire from stationary positions. The telescopic sight mounted coaxially, with the gun provided magnification and a precise aiming reticle. Japanese tank sights were crude by comparison, offering minimal magnification and requiring experienced gunners to estimate range and trajectory. The Sherman's sight made even inexperienced gunners more effective. The power traverse, operated by electric motors drawing power from the tank's generators, could rotate the turret 360 degrees in less than 15 seconds. Japanese turrets rotated by hand crank, requiring sustained physical effort from the commander and taking over a minute for a complete rotation. These differences weren't just matters of comfort or convenience. They were fundamental advantages that determined combat effectiveness. A Sherman crew could identify a target, traverse onto it, range it accurately, and fire within seconds. A Japanese tank crew performing the same tasks required far longer, giving the Americans time for multiple shots before Japanese gunners could even aim properly. After 5 days of intensive examination, Hayashi compiled his findings into a detailed technical report. The document ran to 73 pages, including technical drawings, calculations, and operational assessments. The conclusion section was blunt in its assessment of Japanese armor capabilities relative to American standards. The Sherman represented a generation of advancement beyond current Japanese tank designs. Its armor protection exceeded anything Japan had fielded or even planned to field in the immediate future. Its firepower could engage and destroy any Japanese tank from ranges where return fire was impossible. Its mobility was adequate, not exceptional by European standards but entirely sufficient for Pacific theater operations. Its reliability appeared excellent based on the condition of this captured vehicle, which showed minimal wear despite obvious field use. Most critically, the Sherman was not a specialist vehicle or a limited production design. Intelligence reports indicated the Americans were producing these tanks by the thousands. Factory production had reached hundreds of vehicles per month at multiple facilities. The industrial capacity required to achieve such production rates was staggering, far exceeding anything Japanese industry could hope to match even under peacetime conditions. During war, with resources increasingly scarce and factories subject to air attack, closing the gap was simply impossible. Hayashi sent his report through command channels to Imperial General Headquarters in Tokyo. He included a specific recommendation that tactical doctrine be revised immediately to account for Sherman capabilities. Japanese tank units could not engage Shermans in open combat under any circumstances. The disparity in firepower, protection, and fire control systems made such engagements suicidal. Japanese armor should be reserved for infantry support missions only, engaging fixed fortifications and enemy infantry positions while avoiding direct combat with American tanks whenever possible. The report reached Tokyo in August 1943. Staff officers at the Army Technical Bureau read it carefully. They consulted with their own armor specialists, who confirmed Hayashi's technical assessments. The mathematics of armor penetration was not subject to interpretation. The Sherman's 75mm gun could indeed destroy Japanese tanks at extreme ranges. Japanese guns could not effectively engage Shermans except at suicidally close distances, but acknowledging these facts officially was politically impossible. Japan's propaganda emphasized fighting spirit, superior tactics, and inevitable victory through determination and sacrifice. Admitting that Japanese tanks were hopelessly outclassed by American designs would undermine morale and contradict the carefully constructed narrative of Japanese technological prowess. The report was classified, restricted to senior technical officers, and filed away. Tactical doctrine was not revised. Tank crews were not informed of the specific vulnerabilities of their equipment. The war continued as before. With Japanese armor units committed to combat missions, they had no realistic chance of accomplishing successfully. Meanwhile, in the field, tank crews were beginning to learn these lessons through bitter experience. The first major engagement between Sherman tanks and Japanese armor in large numbers occurred on Tarawa in November 1943. The Japanese had 7 Type 95 Ha-Go light tanks defending the island, positioned to counterattack American landing forces. The Marines brought Shermans ashore from LVT Amtrak vehicles, landing them directly on the beach to provide immediate fire support. The Japanese tank attack, launched on the second day of the battle, was brief and catastrophic. Sherman crews engaged the Hagos at ranges exceeding 1,000 yards, destroying 5 of the 7 Japanese tanks before they could close to effective range. The remaining 2 tanks maneuvered into covered positions and attempted to engage from ambush at closer range. Both were destroyed within minutes by 75mm fire that penetrated their thin armor easily. Not a single Sherman was damaged in the engagement. Similar patterns emerged on Kwajalein in February 1944, on Saipan in June, and on every subsequent island where Japanese armor opposed American landings. The tactical arithmetic was brutally simple. Japanese tanks could not penetrate Sherman armor except at very close range. Shermans could destroy Japanese tanks at any combat range. In open terrain, where mutual observation was possible, Japanese tanks died without accomplishing anything. In close terrain, where ranges were shorter, Japanese tanks might get close enough to fire, but Sherman crews with better vision equipment and faster target acquisition usually shot first. Japanese tank crews who survived these engagements reported consistent experiences. They described seeing Shermans at distances where engagement was impossible. They described firing at American tanks and watching their rounds bounce off with no effect. They described the devastating impact of 75mm rounds penetrating their armor, tearing through the interior, destroying equipment and killing crew members. Many described the psychological impact of realizing their tanks offered no protection, that the armor they had trusted was worthless against American guns. One captured tank commander from the 9th Tank Regiment on Saipan told American interrogators that his first engagement with a Sherman had occurred at approximately 800 meters distance. He had identified the American tank, ordered his gunner to fire, and watched the 57mm armor-piercing round strike the Sherman's turret front. The round had bounced away, leaving only a bright scar on the armor. The Sherman had returned fire 3 seconds later. The 75mm round had struck his Type 97 Chiha tank just below the turret ring, penetrated the hull armor, and continued through the fighting compartment. The shell had struck the ammunition racks, detonating several 57mm rounds. The explosion had killed his gunner instantly and severely wounded his loader. He had ordered his driver to reverse into cover, abandoning the position before the Sherman could fire again. That commander, Lieutenant Hiroshi Yamamoto, had commanded tanks since 1941. He had fought in the Philippines, in the Netherlands, East Indies, and across the Pacific. He considered himself experienced, competent, well-trained. But after encountering Shermans on Saipan, he understood that experience and training meant nothing when your equipment was fundamentally inadequate. He told his interrogators that Japanese tank crews knew they were going to die. The only question was whether they would accomplish anything before being destroyed. Back in Japan, the Army Technical Bureau continued receiving field reports documenting the Sherman's superiority. Every engagement confirmed what Colonel Hayashi's technical examination had revealed. The Sherman could engage Japanese tanks at ranges exceeding 2,000 yards. Japanese tanks could not effectively engage Shermans except at 300 yards or closer. In practical terms, this meant Japanese armor was obsolete, useful only in specialized circumstances where American tanks could not be brought to bear. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The response from Japanese industry was to accelerate development of improved designs that could theoretically match Sherman capabilities. The Type 3 Chi-Nu medium tank mounted a 75mm gun that could penetrate the Sherman's armor at reasonable combat ranges. The Type 4 Chi-2 mounted an even more powerful gun and had thicker armor. On paper, these designs were competitive with the Sherman. In practice, they existed primarily as prototypes and very limited production runs. The Type 3 Chi-Nu entered production in October 1944 at the Mitsubishi Heavy Industries facility in Tokyo. Production rate was approximately 2 tanks per month. By war's end in August 1945, only 166 Chi-Nus had been built. None saw combat in the Pacific Island battles. All were retained in Japan for the anticipated American invasion of the home islands. The Type 4 Chi-2 existed as only 2 prototypes. The design was sound, mounting a high-velocity 75mm gun in a turret with 75mm of frontal armor. This tank, if produced in quantity, could have engaged Shermans on roughly equal terms, but production never began. Japanese industry simply lacked the capacity to manufacture such complex vehicles, while simultaneously producing aircraft, naval vessels, and the munitions required for defensive operations across the Pacific. The contrast with American production capacity was stark and humiliating for Japanese military planners who understood the implications. The Fisher Tank Arsenal in Michigan, operated by General Motors, produced over 11,000 Sherman tanks during the war years. That single American factory produced more tanks than all Japanese tank production combined for the entire war. Fisher wasn't even the largest Sherman producer. Chrysler's Detroit Tank Arsenal built nearly 8,000 tanks. American Locomotive Company, Baldwin Locomotive Works, Lima Locomotive Works, Pressed Steel Car Company, Pacific Car and Foundry, and Federal Machine and Welder all contributed thousands more. 10 major American manufacturers produced Sherman tanks using mass production techniques perfected through decades of automotive manufacturing experience. Assembly lines, interchangeable parts, standardized components, specialized tooling, all the lessons learned, building millions of civilian vehicles were applied to military production with devastating effectiveness. Japanese tank production, by contrast, remained largely hand-built using skilled craftsmen and traditional manufacturing methods. Production rates were measured in dozens per month, not hundreds. The industrial disparity wasn't limited to quantity. American tanks were more reliable, requiring less maintenance and lasting longer under field conditions. They incorporated features Japanese designers considered unnecessary luxuries, like synchronized transmissions that made driving easier, or power traverse systems that reduced crew fatigue, or extensive vision equipment that improved situational awareness. These features weren't luxuries. They were force multipliers that made American tank crews more effective and improved operational availability. Sherman tanks in the Pacific maintained operational readiness rates exceeding 70%, meaning more than 7 out of 10 tanks were combat-ready at any given time. Japanese tanks, increasingly short of spare parts and maintained by crews with inadequate tools and facilities, struggled to maintain 50% readiness. Mechanical breakdowns claimed as many Japanese tanks as enemy fire, with engines failing, transmissions seizing, and tracks breaking under stress. The captured Sherman at Munda Point, carefully examined by Colonel Hayashi's team in the summer of 1943, told the entire story in microcosm. This single vehicle represented industrial and engineering capabilities Japan could not match. Its armor protection exceeded anything Japanese industry could produce in meaningful quantities. Its firepower could destroy Japanese tanks from distances where return fire was impossible. Its design reflected decades of automotive engineering experience applied to military requirements, and most critically, it was one of tens of thousands being produced at rates that would have seemed fantastic to Japanese observers if they hadn't seen the evidence with their own eyes. The technical reality that Hayashi documented in his 73-page report created an impossible situation for Japanese commanders throughout the Pacific. They had tank units, trained crews, and tactical doctrine built around armored operations, but the equipment itself was obsolete for the war they were actually fighting. Using tanks against American forces meant accepting catastrophic losses for minimal tactical gain. Not using tanks meant abandoning offensive operations and ceding the initiative entirely to enemy forces who could maneuver freely. Some Japanese commanders adapted their tactics to minimize the disadvantages. On Peleliu in September 1944, Colonel Kunio Nakagawa deliberately avoided committing his tanks to counterattacks. Instead, he positioned them in caves and reinforced bunkers, using them as stationary pillboxes with good fields of fire. This tactic negated the mobility advantage Shermans possessed and forced American tanks to approach defensive positions within range of Japanese guns. The approach achieved limited success. Japanese tanks firing from prepared positions could occasionally destroy American vehicles that came too close or exposed vulnerable side armor. But even used as static fortifications, the tanks were vulnerable. Their thin armor could be penetrated by recoilless rifles, bazookas, and even heavy machine guns at close range. Flamethrower tanks could direct napalm into vision ports and hatches, cooking crews alive inside steel, compartments that became ovens. Artillery fire could collapse cave entrances, burying tanks and crews together. On Iwo Jima in February 1945, Lieutenant General Tadamichi Kurebayashi adopted similar defensive tactics. The 26th Tank Regiment, under Colonel Takeichi Nishi, had 23 tanks, a mixture of Type 95 Hargos and Type 97 Chihas. Kurebayashi ordered these tanks buried in the volcanic ash up to their turrets, creating armored bunkers that could support defensive positions without exposing the vulnerable hulls to American fire. The tactic provided some protection, but eliminated the fundamental purpose of having tanks. These vehicles had been designed for mobile warfare, for supporting infantry advances, for exploiting breakthroughs. Buried in static positions, they became expensive machine gun bunkers with limited fields of fire and no ability to maneuver. American forces methodically destroyed them using the same techniques effective against fortification: direct fire from Shermans at close range, demolition charges placed by engineers, and flamethrowers that turned the interior into an inferno. The most comprehensive Japanese analysis of Sherman capabilities came not from combat reports, but from continued technical examination of captured vehicles. By late 1944, Japanese forces had recovered several additional Sherman tanks in various states of damage. Engineers transported these vehicles to facilities in the Philippines, on Formosa, and eventually to Japan itself for detailed study. The examination program expanded beyond simple measurement and calculation. Japanese engineers tested Sherman components to failure, determining design margins and identifying potential weaknesses. They disassembled transmissions to understand the synchronized gear design. They sectioned armor plate to analyze the steel composition and heat treatment. They fired captured weapons to measure actual muzzle velocity, penetration performance, rather than relying on theoretical calculations. Every test confirmed or exceeded the initial assessments from Munda Point. The Sherman's 75mm gun could penetrate 60mm of vertical armor at 1,000 meters with standard M61 armor-piercing shot. At ranges under 500 meters, penetration exceeded 80mm. These weren't theoretical numbers. They were measured results from test firing against captured Japanese tank hulls and armor plate samples. The testing program included a particularly revealing experiment conducted at the Izu Proving Ground south of Tokyo in March 1945. Engineers positioned a Type 97 Chiha tank at various ranges from a captured Sherman and fired the American gun at the Japanese vehicle to document penetration performance. At 2,000 meters, the first shot struck the Chiha's turret front and penetrated cleanly. The round continued through the fighting compartment and exited through the rear hull armor, traveling completely through the tank. Engineers moved the Chiha to 1,500 meters and fired again. The 75mm round struck the frontal hull armor, angled at 15 degrees from vertical. The armor-piercing shot punched through without difficulty, devastating the interior before lodging in the engine compartment. At 1,000 meters, the penetration was so complete that rounds sometimes passed through both sides of the tank, entering the front and exiting the rear after crossing the entire interior length. The test officer, Major Shiro Kobayashi from the Army Technical Bureau, documented each shot with photographs and detailed notes. His report to headquarters was grimly matter-of-fact about the results. The Sherman could destroy any Japanese tank in service from ranges exceeding 2 kilometers under favorable conditions. Japanese tanks could not effectively engage Shermans except at ranges under 300 meters, and even then only by targeting side or rear armor. The disparity was not marginal, it was absolute. Kobayashi included in his report a section comparing Japanese and American tank design philosophy. The analysis was remarkably objective, acknowledging that Japanese approaches had been fundamentally wrong for the type of war that developed in the Pacific. Japanese designers had optimized for weight reduction and mobility, assuming tanks would primarily fight infantry and fortifications in terrain where long-range engagements were rare. This assumption had been correct for operations in China and early Pacific campaigns against poorly equipped opponents. But against American forces with proper anti-tank weapons and their own armor, mobility alone meant nothing. Japanese tanks could maneuver quickly into positions where they were promptly destroyed by superior firepower. The thin armor that reduced weight and improved speed offered no protection against weapons designed to defeat armored vehicles. The light guns that minimized recoil and allowed smaller turrets lacked the penetrating power to defeat modern armor protection. American designers had made different choices based on different assumptions. They assumed their tanks would face peer adversaries with comparable equipment. They built in protection sufficient to resist contemporary anti-tank guns at reasonable combat ranges. They mounted guns powerful enough to defeat enemy armor before getting close enough to be engaged effectively. They accepted the weight penalty these features required, compensating with more powerful engines and robust suspension systems. The philosophical difference reflected deeper industrial and military realities. America had the manufacturing capacity to build 30-ton tanks with thick armor and powerful guns. Japan struggled to produce even 7-ton light tanks in adequate numbers. America could afford the steel, the engine production, and the shipping capacity to deploy. heavy tanks globally. Japan faced chronic shortages of all these resources and had to prioritize aircraft and naval construction over ground force equipment. These limitations weren't temporary or correctable through better design. They were fundamental constraints imposed by industrial capacity and resource availability. No amount of engineering cleverness could overcome the basic fact that Japan could not match American production output. The United States built 49,000 Sherman tanks during the war. Japan built approximately 6,000 tanks of all types combined, including light tankettes that barely qualified as armored vehicles. The numerical disparity meant that even if Japanese tanks had been technically equal to Sherman's, which they emphatically were not, American forces would still have enjoyed overwhelming superiority through sheer quantity. Tank battalions that lost vehicles in combat received replacements within weeks. Japanese tank regiments that suffered losses had no expectation of receiving new equipment. Destroyed tanks were permanent losses that could not be replaced. Japanese tank crews understood these realities better than headquarters staff officers who issued orders based on outdated assumptions. Crews who had faced Shermans in combat knew their equipment was obsolete. They knew engagement meant probable death. They knew that courage and training and tactical skill could not overcome fundamental material disadvantages. Yet they continued fighting because orders required it, and military culture demanded absolute obedience regardless of circumstances. Lieutenant Yamamoto, the tank commander captured on Saipan, described this psychological burden to American interrogators. He had known before the counterattack launched that his chances of survival were minimal. Intelligence reports had described Sherman capabilities. Rumors from other island garrisons had circulated through the ranks. Every tank commander on Saipan understood they were being sent against superior forces with inadequate equipment. The culture of the Imperial Japanese Army permitted no questioning of commands, no matter how suicidal they appeared. Yamamoto had climbed into his Type 97 Chiha, knowing he might not climb out. His crew had performed their pre-combat checks with the ritualistic precision of men preparing for their own funerals. They had advanced across open ground toward the American positions, and the Shermans had destroyed them systematically, one after another, like shooting gallery targets. Yamamoto had survived only through luck. His tank had been hit in a way that disabled it without killing the entire crew. He had managed to evacuate his wounded loader and escape before American infantry reached the wrecked vehicle. Of the 14 tanks that participated in that counterattack, 13 were destroyed within 30 minutes. One commander survived. The tactical objective disrupting the American advance was not achieved. The sacrifice accomplished nothing except adding more names to casualty lists. These experiences were replicated across every Pacific battlefield where Japanese armor encountered American forces. On Luzon in 1945, the 2nd Armored Division under Lieutenant General Shizuo Sakurai committed its remaining tanks to defensive operations around Manila. The results were predictable and catastrophic. Sherman tanks from the American 6th Army systematically destroyed Japanese armor in engagements where the outcome was never in doubt. Japanese tanks could not penetrate Sherman armor. Shermans could destroy Japanese tanks at will. The technical reports that Colonel Hayashi and Major Kobayashi had compiled documented every aspect of this disparity. The 73-page analysis from Munda Point and subsequent test reports from the Izu Proving Ground provided complete technical understanding of why Japanese tanks were obsolete. The mathematics of armor penetration, the physics of shaped charges, the engineering principles behind effective tank design, all of it was thoroughly documented and clearly explained. But documentation changed nothing. Understanding the problem did not provide solutions when the underlying industrial capacity did not exist to implement those solutions. Japanese tank designers knew how to build better vehicles. The Type 3 Chi-Nu and Type 4 Chi-2 demonstrated that Japanese engineers understood modern tank design principles. They could create blueprints for tanks with adequate armor, powerful guns, and modern fire control systems. What they could not do was produce these designs in meaningful quantities. The industrial infrastructure required for mass tank production, specialized steel mills, engine factories, precision machine shops, assembly facilities simply did not exist at the necessary scale. Building this infrastructure would have required years and resources Japan did not possess. Even maintaining existing production levels became increasingly difficult as the war progressed, and American bombing destroyed factories, disrupted transportation, and created critical shortages of raw materials. By early 1945, Japanese tank production had effectively ceased. The few Chinus being assembled at Mitsubishi Heavy Industries were reserved exclusively for homeland defense. No tanks were shipped to Pacific garrisons that desperately needed them. Units that lost vehicles in combat had no expectation of replacement. Tank regiments shrank through attrition until they existed only on paper, their equipment destroyed and their crews reassigned to infantry duties. The captured Sherman at Munda Point, carefully examined in the summer of 1943, had revealed truths that Japanese military leadership could neither accept publicly nor address practically. The technical reality was undeniable. American tanks were superior in every measurable category. The industrial reality was equally undeniable. Japan could not match American production capacity. The tactical reality followed. Inevitably, Japanese tank crews were being sent to die in obsolete vehicles, against an opponent whose material advantages made victory impossible. Colonel Hayashi's report had recommended immediate revision of tactical doctrine to account for Sherman capabilities. The recommendation was ignored because implementing it would require acknowledging defeat before the final battles had even been fought. Admitting that Japanese tanks could not effectively engage American armor would undermine the entire narrative of inevitable victory through superior fighting spirit. The propaganda machine could not accommodate such admissions, so the truth remained classified, and tank crews continued receiving orders that sent them against opponents they could not defeat. The final vindication of Hayashi's analysis came during the planned defense of the Japanese home islands. By August 1945, virtually all remaining Japanese armor had been concentrated in Japan itself, positioned to resist the anticipated American invasion. Approximately 400 tanks remained operational, a mixture of obsolete light tanks and the handful of modern Chi-Nu medium tanks that represented Japan's best effort at matching Sherman capabilities. American invasion planning called for landing operations that would have brought thousands of Sherman tanks ashore, along with the new M26 Pershing heavy tanks that made even the Sherman seem inadequate by comparison. Japanese commanders planning the defense understood perfectly well what would happen. They had read the technical reports. They knew the penetration tables. They understood that their tanks could not survive engagement with American armor, except through tactical surprise at very close range. The defense plan called for tanks to be used primarily as mobile pillboxes, hidden in prepared positions and revealed only when American forces came within a few hundred meters. Even this defensive approach was recognized as desperation rather than sound tactics. It might inflict some casualties, might destroy some Shermans through ambush, but could not prevent eventual defeat. The material disparity was simply too great to overcome through tactics alone. The atomic bombs dropped on Hiroshima and Nagasaki in August 1945 ended the war before these final tank battles could occur. The remaining Japanese armor never faced American Shermans in the climactic engagement that both sides had anticipated. The tanks were surrendered intact, eventually scrapped or distributed to various nations as war trophies and training aids. Colonel Hayashi survived the war and briefly worked with American occupation forces, providing technical information about Japanese tank development programs. He confirmed to American interrogators that Japanese military leadership had understood the obsolescence of their armor as early as mid-1943, when his report on the captured Sherman had documented the technical disparities. He explained that institutional and cultural factors had prevented appropriate tactical responses, that acknowledging material inferiority was politically impossible even when technically undeniable. In post-war analyses, military historians recognized the captured Sherman at Munda Point as a turning point in Japanese understanding of their armored warfare capabilities. The technical examination of that single vehicle, conducted by Hayashi's team in the summer of 1943, revealed truths that 2 more years of combat would only reinforce. Japanese tanks were obsolete, American industrial capacity was overwhelming. The Pacific War's outcome had been determined not by fighting spirit or tactical brilliance, but by production capacity and technical sophistication that Japan could never match. The story of that captured Sherman became a case study in the importance of technical intelligence and the dangers of ignoring uncomfortable truths. The mathematics of armor penetration could not be rationalized away through propaganda or dismissed through appeals to fighting spirit. Physics and metallurgy operated according to laws that did not care about national determination or martial traditions. Japanese tank crews learned these lessons the hard way, dying in vehicles their own technical officers knew were inadequate 2 years before the war ended.